45A MZ, the first 2 bytes of every Windows PE executable ever compiled. Open Any.x in a hex editor. Those 2 bytes are there, stolen from Mark Zbikowski, the Microsoft engineer who designed the format in 1983. Find an MZ at offset 0 in suspicious memory. You have a PE executable hiding there. Welcome to Malware Forensics, where static analysis examines the binary without running it, and dynamic analysis runs it in a sandbox to watch what it does. 2 disciplines, both required, neither sufficient alone, portable executable, the PE format, every windows.exe.dll.sys. Layout, DOS header, 64 bytes, MZ signature, then a pointer to the PE header, DOS stub. The 16-bit this program cannot be run in DOS mode message. PE header signature, PE00, hex 50450000, COFF file header, 20 bytes, machine type, number of sections, timestamp, optional header, entry point, image base, section alignment, magic value 010B for 32-bit, 020B for 64-bit, address of entry point, where execution starts. Then sections, .text, executable code, .data, initialized global variables, .rdata, read-only data, strings, constants, .rsrc, resources, icons, strings, version info, may contain second stage payloads, .idata, import directory, the IAT, import address table, .edata, export directory, functions exposed by DLLs, unusual section names, .pack.upx0, confirm use of specific packers, strings, the first command in any static analysis, strings command on Linux, strings malware.x, default minimum 4 characters, strings -in8 malware.x, minimum 8 characters, reduces noise, strings -el malware.x, 16-bit little endian, Unicode strings, and the better tool, FLOSS, FireEye FLARE, obfuscated string solver, extracts static strings plus strings that are decoded at runtime, strings the simple command would miss, XOR encoded, base 64 encoded, stack strings, strings that indicate malicious behavior, IP addresses, domain names, URLs, registry key paths, run keys, HKLM paths, file paths, Windows, app data, temp. Mutex names, malware uses mutexes to prevent reinfection. Error messages reveal debugging info about the malware family. Encryption strings, AES, RSA, decrypt. Always run FLOSS on unknown malware before deeper analysis. It surfaces the runtime behavior in seconds. PE imports reveal capabilities. The function calls a binary makes tell you what it can do. Dump in /imports on Windows. Objdump-p on Linux. Readp -- imports from the pfull Python library. Key imports to recognize. Create remote thread, virtual allocx, write process memory, code injection. Open process, access another process. Create file mapping and map view of file, shared memory, fileless operation. Regopen keyx and regset value x, registry persistence. Create service and open SC manager service installation. URL download to file, HTTP download. WSA startup, socket connect, network connectivity, crypt encrypt and crypt acquire context, encryption, ransomware indicator, get a sync key state, key logging, set Windows hookx, hook installation, NT query system information, system enumeration, rootkit behavior. Reading the import table is like reading the malware's mission statement. Network plus registry plus crypto equals ransomware. Keylogger imports plus C2 socket equals credential theft. Dynamic analysis. Execute the malware in a controlled environment. Observe behavior. Reveals runtime behavior. Decrypted strings, unpacked code, network connections, file drops, sandbox environments. Cuckoo, Sandbox, the primary open source automated sandbox, self-hosted, highly configurable, Python-based, captures network traffic, API calls, file system changes, registry changes, screenshots. Any.run, cloud-based, interactive, user can interact during execution. Real-time analysis, Sandbox, commercial cloud and on-prem, strong evasion detection. Hybrid analysis from payload security, cloud, free for community. CrowdStrike integration, YARA support, VirusTotal Sandbox, cloud, quick overview, not deep analysis. VMRay, commercial, hypervisor-based, harder for malware to detect. Choose a sandbox for the type of malware. Targeted attacks need VMRay or Joe. Quick triage uses VirusTotal. Interactive analysis of suspicious files uses Any.run. Behavioral monitoring tools on Windows. Process monitor, ProcMon from SICE internals, the primary tool. Monitors file system, registry, process and thread network activity in real time. Essential filters. Process name contains the malware name. Exclude C:\Windows\system32 to reduce noise. Watch for write file to temp, app data, program data, reg set value to run keys, services. Create process for spawning children, connect for network. Process hacker and process explorer. Enhance task managers, API monitor, logs, all Win32. API calls, Wireshark, captures network traffic generated by the malware. Regshot, takes registry snapshots before and after execution. Diff shows every change. FakeNet NG, simulates network services. DNS, HTTP, SMTP, captures C2 traffic without real internet access. Critical for safe sandbox setups. Procedure. Clean baseline VM, start monitors, execute malware, observe 5 to 10 minutes, save logs. Diff with Regshot, revert VM, YARA, rule-based malware identification. Rules define patterns, strings, bytes, condition, and that identify specific malware families. YARA, rule structure. Meta, description, author, date, hash, strings, patterns to match. $MZ, curly brace 4D5A, end curly brace for the MZ header, string literals, hex patterns with wildcards, regular expressions, condition, the logical expression, example, condition, uint16 at 0 equals 0x5 A4D, and file size less than 500 KB, and all of $string star. YARA usage. YARA rule.yar malware.exe, scan a file. YARA-rule.yar/suspicious/directory, recursive scan. YARA-p10 rule.yarpid, scan a running process. Rule sources to know. YARA rules. GitHub, Valhalla from Next.run systems. ESET GitHub, elastic security rules. YARA can scan both files and running process memory. The -p flag scans a specific PID. Memorize the rule structure. It is heavily tested. Anti-analysis techniques. What malware does to detect or evade examiners. Anti-debugging. Is debugger present? Checks the debug flag in PEB. Check remote debugger present. Checks from outside. NT-query information process. Low-level debugger check. Timing attacks with RDTSC measures instruction time. Slower in a debugger, software breakpoint detection, malware checks for 0xCC in its own code, VM and sandbox evasion, CPU ID check, detects hypervisor bit in ECX. Registry checks for VMware tools at HKLM Software VMware Inc. VMware tools, file and process checks. vmtoolsd.exe, vboxservice.exe present. Screen resolution. Sandboxes often use 800 by 600. MAC address OUI. VMware 000C29. VirtualBox 080027. User activity check. Mouse movement, recent files, browser history, sleep and timing. Delays execution to outlast the sandbox timeout. Detection of anti-analysis in the binary. Search for these API calls in the import table. Their presence is itself a malware indicator. Malware analysis fundamentals. MZ header at offset 0 in every PE file. PE sections, text, data, IData, RSRC, strings, and FLOSS for first triage. Imports reveal capabilities, injection plus persistence plus crypto equals ransomware. Cuckoo for automated dynamic analysis, ProcMon for behavioral observation, Regshot for registry diff, YARA for pattern-based identification. Anti-analysis, is debugger present, VM detection, sleep-based timing. Next up, Objective 9.2, malware types and ransomware investigation, VAS-admin delete shadows, the ransomware fingerprint, persistence mechanisms, DGA detection, fileless malware, and LOL bins. The forensic playbook for the most damaging incident type a CHFI examiner faces.